we're going to move on with the next presenter of today. I believe in the program it was listed as a 5-minute presentation, but it is actually a 12-minute presentation. So I would like to introduce now our next speaker, Mohammad Bahry, who is a PhD student here at Guelph, with the title of his presentation, Impact of Rearing Environments on Growth Trajectories and Sexual Maturation in Layer Chickens.
Hello, hope everyone can access my slides.
Yeah, can you put them in present? Oh, there we go.
Okay. Thank you for the introduction and welcome to my presentation. My name is Mohammad Bahry. I would like to speak about the impact of rearing environment on growth trajectories and sexual maturation in layer chickens. So, as it is clear that the reproduction in chicken is under the control of the HPG axis, which relies on stimulatory and inhibitory inputs. Any stimulation from the environment triggers the gene RH neuron in the hypothalamus and secretes the gene RH1. This gene RH1 increases the secretion of LH and FSH from the pituitary. This LH and FSH increases egg production and advanced sexual maturations. Or on the other hand, any negative inputs from the environment increases the gene IH production in the hypothalamus, and this gene IH downregulates the function of gene RH neuron in the hypothalamus, and the LH and FSH neuron in the pituitary downregulates the egg production in chickens. Recently, we found that metabolic triggers independently initiate sexual maturation in chickens when a threshold is met. In this experiment we wanted to evaluate the impact of the growth trajectory on sexual maturation in chickens. We had 2x3 factorial design, experimental design, with 2 strain white, Lohmann white birds and Lohmann brown, with 3 treatments at lip group, recommended birds, and birds receiving 20% below the recommended, which we call it restricted birds. As we see here, body weight of the birds at first egg was strongly affected by our feeding regions. The birds receiving ad-lib birds had a higher body weight compared to the restricted and recommended birds in both strains. And this increase in body weight had a direct effect on age at first egg. As it is clear in this figure that birds which were reared in restricted condition, they delayed egg production by a couple of weeks compared to the target birds, and it was more pronounced in the brown birds. We found that the birds which were reared in ad-lib condition, they advanced sexual maturation by 1 week compared to the target birds and by 3 weeks compared to the restricted birds. The results from this presentation was presented. The results from this study was presented in CPRF and PSA 2021, and the manuscript is under preparation. It is clear that growth and body composition, as well as the development of the sexual maturation, is also dependent on housing systems. Thus, the idea behind this experiment was to determine whether different housing systems affect metabolic thresholds required to activate the reproductive axis in layers. In this trial, we had day-old layer chicks, Lohmann brown and Lohmann white. We reared these chicks under standard lighting, temperature, and a lip fit. We had 2 types of housing systems, the aviary systems and the conventional cages. Our aviary systems were divided in 3 styles, style 1, style 2, and style 3. All the birds were moved to furnished cages at 17 weeks of age in order to measure the egg production capacity of the birds. Let's have a look what is the difference between these housing styles. In aviary style 1, birds were fairly confined for the first 6 weeks. Then they had a little space to run and perch till 17 weeks of age. In style 2, as we see in the figure, birds had more access to vertical space perches platform during the first 6 weeks. Then they had a little more space to run and perch till 17 weeks of age. In aviary style 3, in fact, it was an open concept. Birds had free access to a much larger area, complexity. Birds had a lot of running and perching till 17 weeks of age. In conventional cages, birds didn't have access to run and perch till 17 weeks of age. At 17 weeks of age, all these birds were moved to furnished cages, which were equipped with nest area in order to have them eggs and measure the egg production of the birds. Body weight was collected biweekly, and we collected samples from 8 weeks to 14 weeks of age biweekly, the blood samples, and from 14 weeks of age to 23 weeks of age weekly. Data were analyzed using the mixed procedure in SAS. In order to further investigate whether our housing system affect the body composition of the birds, we introduced the birds in DEXA scanning machine. After euthanizing the birds, we keep the carcass at 4 degrees Celsius for 24 hours to adjust the core temperature. Then keep these birds inside the freezer till the DEXA analysis. After thawing the birds before putting in the DEXA machine, we thawed the birds. Then birds were introduced to the DEXA machine in uniform position and at random condition or randomly. The results from the body weight of the birds shows that our housing system strongly affected the body weight of the birds. As we see here in the yellow line in both strains, in white strains, and as well as in the brown birds, the conventional cages had the higher body weight compared to the aviary systems. Furthermore, we had a higher body weight in aviary style tree, which was an open concept in brown birds. So this increase in body weight had associated with the fat lean percentage or fat deposition of the birds. At 16 weeks of age, we see that birds which were kept in conventional cages had the higher fat percentage compared to the aviary systems in both strains. The higher body weight and the fat concentration, which was from the DEXA machine, the body composition, associated or affected the steroidal concentration of the birds. As we find that birds which were reared in conventional cages had the higher steroidal concentration at 18 weeks of age. And the brown birds followed the body weight curve. Birds which were inside the reared in open concept or aviary style tree, they had a higher steroidal concentration at 18 weeks of age. This increased in body weight, increased in body composition, and the increase in the steroidal concentration had a direct effect on the egg production of the birds. We find that in the brown birds, birds which were inside the conventional cages, as well as birds in the aviary style tree, which was an open concept, has a higher egg production compared to the other two aviary systems. The same thing in the white birds. We had birds which were reared in conventional cages, advanced egg production, as well as had a higher egg production compared to the two other aviary styles. Interestingly, we had a higher egg production in aviary style 2, which birds had a little more vertical space thrown and perch. So to have a closer look on the musculoskeletal system, we find that the DEXA analysis results show that birds which were the white birds, particularly the white birds which were in conventional cages, had a lower bone area at 16 weeks of age as well as at 23 weeks of age. Furthermore, these birds, the white birds in conventional cages, had a lower bone mineral content at 16 weeks of age and at 23 weeks of age, which these birds had a higher egg production, higher cellular concentration, higher body weight, and as well as higher fat deposition. Furthermore, we found that in white birds, which were inside the aviary style 2, which had a higher egg production, they had a lower bone area as well at 23 weeks of age and bone mineral content at 23 weeks of age. This could be due to the higher egg production. And this lower bone mineral could affect the bone quality and could lead the birds to the bone fracture or poor bone quality in the future as well. So The results in my study indicate that rearing pullets in conventional cages results in increased body weight and carcass fat percentage in both students at 16 weeks of age, while it lowered bone mineral content and bone mineral density, particularly in white birds. The type of aviary systems also had an impact on body weight and body composition of the birds. However, a significant associated impact on egg production was only observed in white birds. I have a special thanks to my supervisor, Professor Gerogel, and my lab mates. And this experiment was supported by NCRC, EFC, Canadian First Research Excellence Fund, and Ontario Minister of Agriculture, Food and Rural Affairs. Thank you for your attention. I appreciate your questions.
Thank you for a great presentation, Mohammad. And that's not the first time I see your data. I've seen them quite a few times over the last couple of weeks. And one thing I find perplexing is that difference between aviary, I believe it's aviary 3 that had an impact on the browns and aviary 2 that had an impact on the whites. And I'm just wondering, what is the main difference between those two systems? Like the ones that impact the whites versus the one that impacts
actually, in the aviary studies, there were no differences, but this could be the physiology of the birds. Because the white birds, as we know, they are more active, they are more running, more perches compared to the brown birds. This could be the differences between the impact of the housing system on the birds.
Yeah, no, I tend to agree. And on top of that, the brown birds tend to not use the vertical space as
yes, because they are not more active. They are not using the vertical space running, perching a lot compared to the white.
No, and on the other end, I found that very interesting that it has more impact on the production in the whites than in the browns. So it looks like the browns maybe then they are, I don't know, less fine-tuned or.
Yes, you're right. The browns are a little bit lazy. So when they are staying in somewhere, they don't fond of, they're not interested to move around unless they are thirsty or they are hungry to find the food. And the white birds are so active, so they're moving around, they want to investigate the environment. So that could be another part of that.
Yeah, so taken together, that really kind of points to the fact that, in fact, it's not a housing system fits all birds, you know, and in fact, the housing system may be actually more important to be adjusted for the strain. And I think some of that will be as well covered in the talk, in some of the talks tomorrow.